Hello guys, today I want to show you how you can find the derivative of ln x using implicit differentiation. So this is pretty simple, and the only thing that you need to do is basically, define some functions and understand inverse functions. That is something that is very important. And if you understand those things, what I'm about to show you is going to be pretty simple, okay? So let's begin. So if we want to find the derivative of ln x, and we want to do that by using implicit differentiation, we're going to define two functions, okay? One function and the inverse function of that previous function. So let's say that we have a function w, okay? I'm not going to write w parentheses input. I'm just going to say w, and it's going to be a function. And we're going to say that w is equal to ln x, okay? This is the first function that we have. Now, so that we can use implicit differentiation, we need to find the inverse function of w. And since w is equal to ln x, the inverse function of ln x we know is going to be equal to e to the x, okay? And we're going to define that inverse function as, let's call it y, okay? Just y. And y we know would be e to the x. Now, I hope you know this. You should know this from pre-calculus or, even your algebra classes, that there is a relationship between the function and its inverse, a function and its inverse function, and that relationship is that if you evaluate, let's say y at w, then this should be equal to x. And if you're wondering why, well, remember that this y evaluated at w is going to be equal to y, where x is equal to w. So you have e to the x equals w, so ln x. And I hope that there is a property of logarithms that allows us to cancel out e and ln, and that would be equal to x, okay? So you can see that this is true. Basically, what you have here is, in another notation that you might be more used to, is y evaluated at y to the minus 1 of x, and this is equal to x, okay? This is a relationship that you can express it through an equation, and that is going to be very important because we are going to differentiate this equation to find the derivative of ln x, okay? So what we're going to do is the following. We're going to grab, I'm going to do it like this. So we're going to take the derivative with respect to x of y evaluated at w, and we know this is going to be equal to the derivative evaluated at evaluate the derivative with respect to x of x, okay? You can see that we're just basically differentiating this equation, grabbing this expression and this one. The derivative of this is going to be equal to the derivative of this because these two things are equal. So now we know that we can replace yw with e to the ln x, and we know that e to the ln x is also going to be equal to, I'm going to write it over here, e to the ln x is also going to be equal to w, okay? So you can write e to the w. So you can write this as the following. So I'm going to say we continue over here, and we say this is the derivative with respect to x of e to the w, because y evaluated at w is going to be equal to e to the w, and this is equal to the derivative of x. We know it's just going to be 1, okay? This x just comes from this equation, okay, from this x over here. So now we only need to find, now we can use implicit differentiation to find the dw over dx, because that would be the derivative of ln x, okay? dw over dx would be ln prime, okay? So let's do that. Now we know that the derivative of e to the w is going to be the derivative with respect to w of e to the w times the derivative of w with respect to x, okay? And we know this would be equal to 1. And now we only need to solve for the w. So we know that the derivative of e to the w is going to be e to the w. So we have e to the w times dw over dx, and this equals 1. And now we get from that dw is going to be equal to dx 1 over e to the w, okay? And now I believe you can see what is going to happen. This would be the implicit solution. Let me write that over here. This is the implicit solution because we want to have the derivative in terms of x, but we have the function w in there. So this would be the implicit solution, okay? But we want the explicit solution. So we can turn this by substituting w equals ln x into this. So we would get that the derivative of ln x is going to be equal to 1 over e to the ln x, okay? And remember that e to the ln x is going to be equal to x. So you just simply have 1 over x, okay? And this is basically the entire problem. This is how you can find the derivative of ln x using implicit differentiation, okay? This is where you can see the implicit differentiation happening. You have w, which is going to be a function of x, and we show that by multiplying by the derivative of w with respect to x, okay? So yeah, I believe that should be everything. The only thing that probably we could have gone, we could have gone over more, more rigorously. I believe it could have been this property, e to the ln x is equal to e to the ln x is equal to x. And actually, just as a bonus, I'm actually going to give you the proof real quick on this side, so you can see it. So basically, so that you can prove that, you're going to find a variable y, and you're going to say that y is equal to ln x. Now you want to take ln on both sides. You're going to have ln e to the ln x. There is a property of logarithms that allows you to move ln x as a product. So you have ln y is equal to ln x times ln e. Ln e equals 1, so you get ln y equals ln x. And since you're taking the log on both sides, well, you know that that y is equal to x, and since y is also equal to e to the ln x, you can write this is also equal to e to the ln x. And here's the proof, okay? I believe that was like the only thing we didn't really touch in this video, besides, the implicit differentiation. But now, if you didn't know that this is true, well, now you know. So yep, I believe that has been everything. And I hope you learned something today, maybe, this proof, or how you can use implicit differentiation to find the derivative of ln x. So yep, that has been everything. I hope you enjoyed this video, and see you in the following one. Bye.